Good afternoon, everyone. Uh, so today I'll be representing Dr. Gilbert Baraza Mugeni, who is from Masinde Muliro University, and also Leonard Mabele. I am Stephen Yetich. I am an IoT researcher at iLab Africa, Strathmore University. So this particular research project that was funded by the National Research Fund is a new way to think or to try to tackle a problem that is currently facing us in the country. So how do we get to collect data using technologies that have been developed or new technologies that can enable us to better respond to disaster. So this is termed as a model and an implementation of an Internet of Things based data analytics, big data analytics system for disaster prediction and management. So this particular project is a research project born or carried out by 4 universities, with the lead partner being Masinde Muliro University, and other universities, Strathmore University, Kibabii University, and Laikipia University. So when we talk about disaster, right, in the Kenyan context, we usually think of the two things: floods and drought. So if you can look at some of the news articles that are there, you can see when we even just talk about floods, the first thing that comes into your mind is there's some people who've been carried by water, or there's a particular river that has been blocked, or there's particular goods that were supposed to go to some place, but it didn't get there. When you look at droughts, you think of the hard-earned or the particular animals or crops that farmers or pastoralists have kept are affected, and in this case, it affects their livelihood. And if you look at an economic impact, it affects their livelihood at a very greater. So, when you look at this particular problem, one of the things that brings about or makes the particular effects to be very bad is because there's a difficulty in obtaining timely and relevant information. And then in this regard, when we look at this, is in terms of now disaster preparedness or risk management, what is required is if we get timely information, we're able to prepare ourselves for such disasters, and the overall effect is reduced loss of lives as one of the key examples. So in this research, we present an opportunity to tackle this particular problem, and one key opportunity is to use emerging technologies, such as the Internet of Things. So how do we do this? Collect pieces of information that are very key in terms of determining how these disasters can occur, or the time it can actually occur. If you collect it in time, we are able to better prepare ourselves. That in itself is the key part of this particular presentation. Our objectives are four objectives. I'll just stick to one. One is I'll stick to two. So first is to kind of understand what are we facing, what's the current problem that you have. So we do a situation analysis. And then the second part is now building or to analyze, design, prototype an IoT system or a big data ecosystem that can manage these particular disasters. The others is now pilot this particular project, and then be able to show you on some of the things that we were able to achieve. In terms of the research, how we carried the research, it was divided into work packages. So this was split based on the objectives that just shown you. So the work packages was first to get the situation analysis. How do we prepare ourselves as a country? What's the current situation? What are the policies that are there? How do people perceive some of these disasters? And in terms of just looking at the system that we create, or the IoT system, how prepared are the people to actually adopt it for future use cases? So I'd like you to keep that in mind. So the third and fourth work packages was developing the system, and then now deploying it, and then after that is kind of now coming up with an impact assessment and evaluation, and also a bit of knowledge transfer. So the way this particular system looked like from a high-level architecture is first we build the IoT devices. Now, I've talked about IoT devices, and I do not want to assume that everybody knows what an IoT device is. But the first and fundamental item in building an IoT device is to collect the piece of information that you require. So in this case, we have a flood monitoring device. This is now dubbed as our IoT device. Now, the IoT device collects water level, temperature, soil moisture, and humidity. Right? Now, after that, we send that piece of information to the cloud. So the cloud is where we now store the data and be able to analyze it. One particular difference from the traditional methods that we have is in this particular research, we use a technology called LoRa. So it's specifically built for solutions for IoT technology. Why it's very key, it's important, it can cover a large area. So imagine 16 kilometers, you have one device, you have a gateway, so this is the one that will take in the piece of information, and you have multiple devices that can span up to 16-kilometer radius. So to kind of give you a picture of what 16 kilometer looks like, so imagine you're at Nairobi CBD. 16 kilometers from there is Rongai, Kasarani, Syokimau, and if you stretch it further, towards Kikuyu. So in a place where it's not densely populated, you can spread many devices that can be able to collect information within this particular area. Now that one presents a very big opportunity in terms of collecting information. And then the last particular part is actually disseminating this particular information. So one of the things that you consider is who are the end users. And then, so how it will look on the other side of the end device is now in terms of what you analyze, so the disaster prediction, the models that you build, are they able to predict and let's say a particular days you'll get rainfall, particular days you'll get, let's say high humidity. Oh. Now, just looking at the, so this high-level architecture is what essentially is the particular process that we build on our system architecture. Now, some of the things that, or the outcomes that we had is first, now the devices, this is how it looks like, as you can see on the screen. Now we worked, since we were working with 4 universities, we deployed it in the sites itself. So in Kibabii, in Laikipia, in Kakamega, and also in Strathmore University, so that is Nairobi CBD. So the devices were able to collect information from that, and then we're able to now get that particular data in a unified disaster prediction management. So here we are able to get a trend of that data in real time. So if it sends right now, in the next 1 minute, you'll be able to see it on that particular dashboard. So it shows you a trend of data that has been there within that particular area. This particular platform also has a bit of, it has a map that shows you now within an area how that particular how that particular area looks like in terms of the data that has been collected. So the link to access it, it's that link that you can see on your screen. So the models are also plugged into some of the visualizations that you can see on that particular platform. So in terms of the predictions, now another thing that came about when we did situation analysis and also some of the preliminary activities now kind of form the devices that you're going to build and how it's going to look like. We did a study, so we published a paper. It's called Determinants for the Adoption of IoT for Flood and Drought and Disaster Management in Kenya. What we are looking at in this particular study is how do people, what affects or what will affect if you decide to use IoT to ensure, or in this case, to now look at preventing disasters or building devices or IoT devices that will essentially help in such cases. So there are three things, there are three key factors. So this was a survey that we carried with 82 respondents, so in different various fields within this particular industry of disaster management. So there are three things: perceived ease of use, perceived knowledge, relative advantage. What these three things cover is, so the first thing, ease of use. Is that particular device easy to use? So the respondent found that if it was easy to use, then they would be able to adopt it. If it wasn't, then they won't. Now the perceived knowledge. Now this is very interesting because if somebody doesn't understand what they're working with, they essentially won't. So this is perceived knowledge. The third bit is relative advantage. As these particular devices or technologies that you're using supersede whatever is there, so the traditional one. Now, why this is important is if the users of or the end users see that there is no advantage to what exists, the adoption will be very, very little. So when you're considering any application, especially in this particular area, when you're looking at, these are the three things that you need to keep in mind when you will be giving out to users. The other bits we did as part of this particular study, we did capacity building programs. So we ensure that every time we visit the university, one, undergraduate students. So the undergraduate students, these are the students who are enthusiastic about this particular field or are interested in terms of tackling such issues. Why this is important, we leave those devices in those particular institutions or within that particular, we might not go there at the same time. So we relied a lot in terms of the students and also the postgraduate students who are there to assist us in maintaining some of this. Additionally, some of the things that, okay. So additionally, what this helps also is helping the students to kind of understand whatever they're learning and how it practically translates to what can be used now to tackle some of the challenges that we have. So we did this when we went there to assess the site, when we went there to deploy the devices, and even after deploying the devices. Some of them are also, they've been accessing the data that we've been collecting. Then one particular thing is, at the last bit, we convened a workshop where we were able to discuss everything that has happened within the study and come up with findings and recommendations for this research. So just to finish off, this is the last bit. It's very important, as you can see some of the recommendations, I'll just pick three, very important. So number one, we need to formulate ways where we can rapidly adopt these technologies. It's very important that we try and test out these technologies because they've been built and they have certain advantages that can enable us prepare ourselves for the worst. If we do it fast, we'll be able to more or less mitigate some of these results. How, and then the second bit is but now the big data part is now where how do we need to create ways to add feedback to the data that we have. So if you can think, we're collecting information from the environment. That is not the only piece of data that will only assist in terms of forming an advisory that we need to be ready. So when you look at this, having feedback from users, so that's in form of images, texts, is one of the things that would help us a lot in terms of building this early warning system. And then the third one, which is very, very important, is you might be the only one who builds, or us building some of these particular solutions. But when we don't train people on these technologies or how to use it, we will always fail in terms of improving or having innovations within this particular space. So training is, or actually training up these particular technical skills in IoT, disaster prediction management, is very important. Carrying stakeholder meetings is very important so that everybody understands their role in this particular. The other ones just form parts of the things that enable these particular projects to be successful. So you can reach us through this. You can reach us through our contacts here. This project it had a lot. So if you want to get more about this project, you can just visit us on the booth there. You can see some of the devices that are there. Yeah, thank you for this opportunity.